These are the notes for 4-6. So we're sticking with the idea of modeling and setting up, using a mathematical model to set up and solve problems. So the situation framing these notes is that we have a pumpkin pie bakery, and it's run exclusively by mathematicians, and they sell perfectly circular pies. Of course they do. So the most popular pie is pumpkin pie, and it sells for $19 a pie. And so we go into the scenario here. The number of pies made each day can vary. If they sell 15 pies in a day, how much money or revenue will they bring in? So we have to find the total money, total revenue. And so we know that that total revenue is we have to kind of come up with how we find that total revenue. And so we know that it's going to be the cost of a pie times the number of pies, right? So I kind of abbreviated cost of pie times number of pies, right? And so we can get a total by multiplication. So the cost of a pie is $19, and we have 15 pies that we've sold, and so 19 times 15, if you can grab a calculator on that, I think of it as 20 times 15, that's 300, but that's one too many, so subtracting 15 from that is 285. So we know that the revenue is $285 from selling pumpkin pies for that day. And so what we do then is, we have this expression that relates the price per pie and the number of pies and the total amount of money. And so we're going to use that and rearrange that for the other two sections. So if they brought in $513 from pie sales, how many pies? So maybe if I color code this, how many pies must they have sold? It's unusual wording. So maybe I should have the cost of a pie be, let's make that red, and maybe the number of pies, since I already highlighted that in green, let's make that green, right? And so the cost of a pie is red, and the number of pies is green. Okay, so we have that relationship. So now we can use that relationship and solve for the missing piece of information. So we know we have a revenue of $513. We know that the cost of one pie is $19. And so we can answer the question of how many pies must they have sold. And so just isolating X, right, means we're dividing each side by 19. And so we get how many pies is 53 divided by 19, which is 27 pies. So it's coming up with a model, and then it's using that model to answer what I would call situational questions, right? Contextual, so to speak, questions. And so this last one says, how much money will they bring in if they sell N pies in a day? So now we're really starting to get into the writing of this expression. So the idea is we've got some constraints or some fixed numbers, and we got some numbers that can vary, right? The fixed number is 19, right? We know that a pie costs $19, at least right now it does. And so the numbers that can vary are how many pies we sell and how much total money we get from selling those pies. So we can come up with an expression to relate and this is where I'm going to start abbreviating, the revenue equals, right, the cost of a pie. And since that's a constant, we're just going to put in the number 19 and times the number of pies. And I used X, but maybe we want to use N for number of pies. So there would be like a viable formula or equation for this situation, for this context, so to speak. So that's kind of the idea here. So let's try it again with this section. The bakery has fixed expenses per day, like rent and equipment and utilities. The costs of the bakery, this costs the bakery $85 per day. They also have variable costs, which is the price for ingredients, like when they make pies. So, and that is $3.50 per day. Okay, so let's look at this scenario here. We have these fixed costs. I'll make them red again. So we have fixed expenses. And so those are things like, you know, rent, equipment, utilities, right? Those don't really change on a day-to-day basis. And so that fixed number is $85 per day. And then they have this variable number. So this variable number is for ingredients, right? If you sell a lot of pies, you pay a lot of money for ingredients because you're buying a lot of ingredients. And that's $3.50 per pie. So if the bakery makes 15 pies a day, what is the total cost of expenses? So we're talking about, these are all expenses here. This is all money they have to pay out. So we're looking at some sort of total again. And so we have a total. And that total is going to be related to, kind of related to the problem above, right? We're going to have these fixed costs. So the $85 here, the $85 for all our what we would call overhead, those costs that we pay even if we don't sell anything, is $85. And then for each pie, we're going to spend $3.50. So we're going to make 15 pies. So we're going to sell we're going to need $3.50 to buy ingredients for each pie. And so that's times 15 then. And so, so that's going to give us a total of $3.50 times 15 plus 85 is $137.50. And so now we're using that relationship now to solve different scenarios, just like above, right? If the bakery spent $179.50 in the total cost of expenses, so this is the total cost, how many pies must they have made? So now we're going back and rearranging this to solve for the number of pies. So now we know that our total is $179.50, and we know we have fixed costs. 85 is going to be what it takes to run that facility and make no pies, really. And $3.50 for every pie. Let's call that N, like we did, like we agreed upon for the variable in part C above. So we have to solve that. So we got to subtract the 85 from both sides, and that's $85. So I'll put the 0, 0 there, right? We got to get that decimal lined up. And so we have 94.50. 94.50 equals 350N, 3.5N, and so N equals, when I divide by 3.5, there we go. I can zoom in there. When I divide by 3.5, or 3.50, same thing, then I get 27 pies. Okay, and it says how much are the total cost of pies if they make N pies a day. So again, they're going after a total expenses. I think I said total costs. That was I wasn't reading carefully. Total expenses, right? So we're going after like what we did in part C, right? We want to generalize this for any number of pies. So our cost then, we'll just call it C for cost, is that 85, that's a constant, right? That's our overhead. So that's going to be 85 plus, and then 3.5 or 3.50 N. So that's going to be our expression, our model, so to speak, for the cost of making pies in that facility. So we're kind of talking about two things, right? We're talking about how much money is coming in, right? And kind of big picture here. This is the revenue, or the money coming in, and this is the cost. So we're now going to tie those two things together. And so then now, if you notice, this last question has to deal with profit. So if we want profit, then that's the money left over after we pay all our bills and bring in all that money. So that profit then is going to be the total revenue. I guess I could call that R for revenue. Maybe that's not a bad idea. We can call this R for revenue. So so that profit is going to be our revenue, what we're bringing in minus our cost, what's going out. And so so that's what our profit is. So our in general terms then, our profit is going to equal, going back to our equations, is going to equal 19N. Remember, 19 was a constant. That was the cost per pie. 19N minus our costs, which were 85. Remember, that was a constant because that's our overhead. And then our cost for ingredients, $3.50 for every pie. So there's our profit expression. And so so really, I think now that I looked at what I just wrote, that is really the answer for part B. So I'm just going to slide that down there. Okay, it says if the bakery sells 15 pies in a day, how much is their profit? So this we can just pull right from the questions above, right? Because we were talking about 15 pies in number 1 and number 2. So if we sell 15 pies, we got $285. We got $285, and to make 15 pies, it cost us $137.50. That was from part A in both of those. And so our profit here is, when we subtract those things, we get $147.50. Oops. In profit, okay. Okay, and then we did part B already. What is the bakery's profit per pie if they sell 15 pies? So profit per pie. So in other words, we get $147.50 for 15 pies. So we just need to divide that by 15. And so our profit per pie then is $9.83. So we sell a pie for $19. We get that much profit. So it costs just under $10 to make a pie, which you might think, well, how does that work? Because it costs $3.50 for ingredients. But remember, we got this cost, this fixed cost here, our overhead, so to speak, and we got to factor that into a pie. So if we take this divided by 15, that's the extra $6.33 to make up that total. And it says, what is the bakery's profit per pie if they sell N pies? So we have to go back to our general expression N, right? So our profit per pie then for N pies is going to be that expression. Now, this expression can actually be simplified. Maybe we need to come back up here and simplify this a little bit. We have 19, because I have a 19N, and then if I distribute here, right, then I have minus 85 and minus 3.50, 350N. And so 19 minus 350 is, let's see, 19 minus 3 is 16, minus 50 is 1550, and minus 85. I'm running out of room here. Let me resize that a little bit. There we go, minus 85. So that is a simpler expression, but it means the same thing. So the profit per pi then is going to be 15.50 n minus 85 all over n. That is going to be the profit per pi expression. Okay. Okay, so the bakery is deciding, this last question here, the bakery is deciding how many pies they should make, how the profit per pie changed based on the number of pies they make. Explain. So if we think about this, so we're looking at how many pies we should make. So we're looking at changing n, basically, right? So that's kind of where this is going. I've kind of run out of colors here. Deciding how many pies they should make. So that is changing n. So so I mean, we can go back and say, well, the more pies they make, the higher their profit is. Because the bigger n is getting, right? So we can see that right back here in part B. The more pies they make, the bigger this number gets, and since this is fixed, the bigger this whole total gets, because the 85 is that overhead that's not going to change. So that's really, I think, if we look at the profit expression in this form, it's probably the easiest to draw the conclusion that increasing n increases profit because $85 is fixed, right? That's that overhead I keep referencing. That's the utilities and the rent and et cetera. So there's a rational explanation or justification for that. This is the word I'm looking for. Okay, so as we kind of shift to checking our understanding here, let's just kind of look at summarizing what's going on here. So really big picture, we're coming up with functions, and we are substituting in numbers, and we're combining functions. So if we come back and look at this, we combined functions right here to come up with a profit expression, right? We took our revenue minus our costs. So we had relatively simple expressions here. This is getting more complicated, the profit expression, but we can combine those functions. So that is our learning target number 1, is combining functions. Okay, we can add, subtract, multiply, or divide functions. In general terms, we can add, subtract, multiply, or divide expressions. Okay, or function. I'll call them expressions. As we see fit. We subtracted 2 functions to get our profit. We can do those things. And then we simplified it. And simplify. So in other words, coming back here to question 3, we took our profit minus our revenue, revenue minus our costs, and we simplified it to come up with this expression that was easier to work with. Just a quick note here. Remember that that's probably not a good symbol to use because that's the multiply symbol. So a quick note here. If you are multiplying or dividing, make sure you use parentheses or brackets. I usually call them brackets. Around the function. Whoops, I spelled that wrong. There we go. Okay, so the other focus we had here, learning target number 2, is evaluating, right? We came up with lots of functions and we evaluated those functions or those expressions. When we evaluated the combination, we used that combination and the original functions themselves. So that involved substituting in values, right? And we could do that, and although it wasn't in the notes, I see it in the checking your understanding. We can also, we plugged in the input and substituted in, but we could also substitute values from tables and graphs. We can get information from tables and graphs, and the only reason I'm mentioning it is because of the check your understanding question here. So we can get values from tables and values from graphs and plug in values. So looking at the check your understanding, is more general than those specific pi scenario that we had. So when we're looking at checking your understanding here, we're looking at really general terms like, here's a real general expression, h of 2 plus f of 2, right? Well, we have to figure out where function h is. So here's function h. So here's function h of 2. And function f is given to us as a graph. So if this is function f here, then f of 2 is right here. And we can add those two values together. So that's what I mean was we're talking real general terms. And then we can change our input value to 7. That's what's happening here, right? We're changing our input value to 7, and we're taking function g, which means we have some algebra to do, put in 7 and get an answer, and then f of 7 is right off of that graph again, which is here. So that's the general things you're going to do as you check your understanding here. So you're going to work on this check your understanding, and then I'll just write it up here. Check your understanding and then verify your answers. And you can do that in Blackboard with the answer key. So in Blackboard I have an answer key for section 4.6, and that you can look at, and it's a PDF